In our last section of this chapter, section 8.8, we are going to apply trig ratios. So we have 4 examples we're going to go through. Our first one says to use trig ratios to find the indicated values, x and y. So if we look at x, we have 28 degrees is straight across, so in this case x is our opposite. And we want to use the other value that we know. We only want one unknown, so that makes this 9 the adjacent. So if I set up this ratio, I know that the tangent, because if I'm using opposite and adjacent, that's going to be tangent. Tangent of 28 degrees is equal to my opposite over adjacent, which is x over 9. So now if I need to solve for this, if I have tangent 28, I plug that into my calculator, or look at my table, I have 0.532 is equal to x over 9. To solve for x, I can multiply both sides by 9, and I get 4.79 is equal to x. Then for y, 28 degrees is still the angle I'm looking at, but now y is my adjacent. Sorry, not adjacent. Y is my hypotenuse. It's my longest side. Now remember, my hypotenuse is always straight across from the 90-degree angle. This is our hypotenuse. And now I know what my x value is. That's 4.79. So I could use either the opposite or the adjacent. I'm going to use the adjacent just because 9 is a whole number. It's easier for me to use. So if I'm looking at my hypotenuse and adjacent, I know that that is going to involve cosine. Cosine of 28 degrees equals adjacent over hypotenuse, which gives me 9 over y. When I plug cosine 28 into my calculator or look at the table, I get 0.883. Multiply both sides by y to get the y on top of my fraction. So I have y times 0.83, sorry, 883 equals 9. And now I can divide by 0.883. My y value gives me 10.19. Okay, so that is how I can use my trig ratios to solve unknowns in a problem with the right triangle. So if I look at this next one, I see my given piece of information over here in relation to this angle that I'm given. This is my adjacent. If I'm looking at t first, I know t is my hypotenuse. It's the longest side. So I need a trig ratio that relates adjacent and hypotenuse, which I know is cosine. So cosine of 46 is going to equal adjacent over hypotenuse, which is 60 over t. Cosine of 46 gives me 0.695. Multiply both sides by t. T times 0.695 is 60. Divide by 0.695. And my t is 86.33. Now to find R, I know R is my opposite. Now, again, I can use my hypotenuse, which I know now, or my adjacent, but since my adjacent is a whole number, I'm going to stick with that. So, opposite over adjacent, I know I'm going to need to use tangent. And those values, the opposite is R and the adjacent is 60. Tangent of 46 in my calculator gives me 1.036, which is R over 60. Multiply both sides by 60. And I'm left with R equals 62.16. Got two more. So number 3, I'm looking for angle D. And if I have my hypotenuse here, it's my longest side, right away. If I'm looking in relation to angle D, I know 10 is going to be the opposite. So if I have the opposite in the hypotenuse, I know it's going to be sine. So my sine of angle D equals opposite over hypotenuse, which is 10 over 15. Now 10 over 15, that is equal to 0.667. And if I have the sine of D equals 0.667, I can either look up that value on my table and see what angle D is going to be, or I can plug in the inverse and figure out what D is. So if I take the inverse sine of 0.667, that is going to give me angle D by itself, which when I plug that into my calculator, I get 42 degrees. And now that I know two angles inside my triangle, this is 90 and this is 42, I can take 180 minus 90 and minus 42, which gives me about, not 58, 48 degrees left for angle F. So I can either just subtract, because I know that there's 180 inside my triangle, or I could try and set up the same trig ratios to find angle F, but this for me is a little faster. I just subtract from 180 and I can get my last angle. Okay, number 4, our last one here. Oops. We know we're looking for angle A. 25 is our hypotenuse, and 20 is adjacent to angle A. If I have adjacent and hypotenuse, I know that's going to be cosine. Adjacent over hypotenuse, which is 20 over 25. Okay, again, I plug that in my calculator. I get 0.8. And I can either look this up on my table and see what angle A is, or I can take the inverse cosine of 0.8. And that is going to give me 37. 180 minus 90 is 90. And then take that 90 and subtract 37. I'm left with 53 degrees for angle B.